Hey, this is Mr. Weaver, and this is Unit 2, Lesson 1, our first lesson of the Ratios and Proportions unit. And this lesson is one of these things is not like the other. After this lesson, you need to be able to use equivalent ratios to describe scaled copies of shapes, and you need to know that two recipes will taste the same if the ingredients are in equivalent ratios. After this lesson, you'll know you're successful if you can determine if scaled shapes use equivalent ratios and describe how equivalent ratios are involved in recipes. So first, what are equivalent ratios? So let's think back to the last unit. We focused a lot on scale factor. We had one shape, and we either made it larger or smaller. In this case, we're going to make it larger. And what we did was looked at the segment of the original and the segment of our scale copy, and we multiplied by a scale factor. So to go from 3.5 to 5.25, we had to multiply by 1.5. No matter what segments we chose, if we chose the corresponding segment, we should have had to multiply by that same scale factor. So 1.5 should have went to 2.25. Even if we chose distances across the shape, B to D was 3, now it's 4.5. We multiplied by that same scale factor. So scale factor took us from one shape to a different shape. When we're talking about equivalent ratios, though, we are going to stay within one shape and then compare that to the other shape. So let's say, for example, I wanted to figure out the ratio of CD to BD. So 1.5 compared to 3. So I'm going to write this as a fraction and then figure out a decimal equivalent. So if I compare 1.5 to 3, that's a ratio of 1/2 or 0.5. If I look at the corresponding distances on our larger shape, 2.25 compared to 4.5, I should get the same ratio, which I do, 0.5. I can tell that these are scale copies of each other because they follow the same ratio. If I were to reverse that and do my ratio of 3 to 1.5, that ratio would be 2. If I were to reverse the other, 4.5 to 2.25, again, it's the same ratio. They are equivalent ratios. No matter which distances I choose to compare, I should always have the same ratios between the two shapes. So if I compare 1.5 and 3.5, my ratio was 0.4285 and so on. Or if I reverse it, 3.5 to 1.5, my ratio is 2.3 repeating. If I check on the other shape, the corresponding segments are 2.25 and 5.25. If I compare those using the top line followed by the diagonal line, I get the same ratio, 0.4285, etc. Or switched 5.25 compared to 2.25, which gives us 2.3 repeating. As long as we compare corresponding sides in the same order, we should end up with the same ratio, and that's another way we can tell if two figures are scale copies of each other. Ratios is going to become an important part of this unit. So if something has an equivalent ratio, that means it follows the same amounts in comparison to each other each time. So we just saw that the side lengths compared to other side lengths followed that same ratio. Well, what if we were dealing with food or drinks, so like recipes? I have part of a pitcher of some kind of red drink here. If I were to be able to separate it out and look closely, this had 3 parts of water, so the white part, it's clear, to 1 part of the red coloring or the red flavoring. So the red is 1 out of every 4 total bars. It's 1/4 of the mixture. If I wanted to make more of that same red drink, and I want it to taste the exact same, I don't want to change the recipe at all. So every time I would need to do 3 parts of water to 1 part of the red drink mix, or make the red drink mix 1/4 of the whole mixture. So every part that I need to add should follow that same exact ratio. So I just filled it up using still 1 part of the red to every 3 parts that I have to put in of the water. Okay, so 1/4 overall of the red. By doing this, we'll end up with the same coloration, and therefore we end up with the same taste. Let's look at 3 other pictures. So there's my first picture, my second picture, and my third picture. Based on the coloration of these 3 pictures, not worrying about how much liquid is in it, which pictures do you expect taste the same? Well, hopefully you said the first one and the third one. They have the same color, and if it was a recipe, they look the same, they probably are going to taste pretty similar. So in the first picture, we had 1 part of our red mixed to 2 parts of water. So 1/3 of the mixture overall. In our last picture, we had the same ratio. It's equivalent. Every part to that was 1 part red to 2 more parts of water. Another part red, 2 more parts of water. It kept the same ratio throughout, and therefore they were the same color. If we look at the second picture, it was darker. There's more red in it. If we were to look closer, we could see that this color, we have 1 part red to 1 part water. So the red ends up making up half of what is there. It's not the same ratio, 1/3 compared to 1/2. Therefore, they are not going to be the same recipe. They are not going to taste the same. In this lesson, we learned that different situations can be described by equivalent ratios. For example, in a recipe, if you want to make something to eat or drink, the taste is only going to be the same if the ratios of the ingredients are equivalent. For example, we talked about making a red drink. Okay, the mixtures of water and drink mix have to be the same ratio for it to taste the same. So 3 parts of water compared to 1 part of our drink mix would be the same ratio if we had 12 parts of water and 4 parts of our drink mix. Okay, 3 times 4 is 12, 1 times 4 is 4. We just made 4 times as much. If we wanted to cut it in half and use half as much water, 3 to 1.5, we would use half as much drink mix, 1 to 0.5. If a mixture was not equivalent to this, the taste would not be the same. We saw that in the last one, where we had a ratio of 1/2 compared to a ratio of 1/3. We also can use equivalent ratios to describe scale figures and scale copies. So A, B, and C here are all scale copies. The ratio of the top length to the side length are all equivalent. But if we look at D, the ratio of the top to the left side is no longer equivalent to the others, and we can see that it is not a scale copy anymore. It didn't follow that same equivalent ratio. It's not a scale copy. So after this lesson, do you know how to determine if scale shapes use equivalent ratios? And can you describe how equivalent ratios would be involved in recipes and keeping the same taste? If not, go back and watch parts of this to deepen your understanding. And that's the end of Unit 2, Lesson 1.